Okay, welcome boys and girls to today's math lesson. We will be talking about mixed numbers and improper fractions. But let's go to our objectives to see more specifically how we will be talking about them. Our first objective is we will identify types of fractions. The second reads, explain the steps in converting improper fractions to mixed numbers and mixed numbers to improper fractions. So what that's telling us that today we're going to cover the different types of fractions, as well as we're going to look at the steps on converting an improper fraction to a mixed number and a mixed number to an improper fraction. That kind of already gives you an idea of the type of fractions that we're going to talk about today. But let's go talk about it some more just to be sure. Type of fraction. Proper fraction, which is something that we're already used to seeing, is a fraction where the numerator is smaller than the denominator. And this is what it looks like. As you can see, the numerator, which we know is the number at the top, is smaller than the denominator, which is the number at the bottom. That's what a proper fraction looks like. Next, we have a mixed number. The main focus for our lesson today is one of them. A mixed number is a whole number and a fraction. This is what it looks like. Now, as you can see, we have our whole number. As we said before, a proper fraction is a fraction in which the numerator is smaller than the denominator. Now let's look at this circle here. This circle obviously has equal parts. How many equal parts? Let's count to find out. 1, 2, 3, 4, 5, 6, 7, 8. So this circle has 8 equal parts. But how many of those parts are shaded? Let's count. 1, 2, 3, 4, 5, 6. So I want you to pause the video right here and try to write the proper fraction for this circle on your own. Now the proper fraction for this circle would be as 6 over 8 because there are 6 shaded parts which goes in the numerator, and there are 8 equal parts which goes in the denominator. Now we're going to look at a few more examples. So once I put the picture on the screen, feel free to pause the video and try to guess the answer before I put it on the screen. There is another circle with equal parts. Now you can pause the video to try and figure out the answer on your own. On the other side, I will count each part, shaded, as well as the shaded parts, and try to figure out how to write this proper fraction. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 equal parts. There are 1, 2, 3, 4, 5, 6 shaded parts. So we would write that fraction as 6 over 9. So there are 6 shaded parts and 9 equal parts. Here's our next shape. Pause the video if you want to. Let's count. 1, 2, 3. There are 3 equal parts. There's 1 shaded part. So this would be written as 1/3, or better known as 1/3. Now let's take a look at our last example. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. How many of them are shaded? 1, 2, 3, 4, 5. So this would be written as 5/8, or 5/8. Next, we'll look at mixed numbers. Remember, we define mixed numbers as mixed number as parts that is a whole and a part that is a fraction. So it's a whole number as well as a fraction combined, hence mixed numbers. The whole number is a number and the fraction is a number. So it's a mixture of numbers. Let's look at an example. Now, as you can see from the diagram, this is one fully shaded part, as well as here is another part, but not all of the parts are shaded. Only 3 out of the 4 parts are shaded. So this is how you would write a mixed number. The fully shaded part would be represented by the whole number, and the other shape would be the part represented as the fraction. The part that is not fully shaded would be represented as the fraction. So since there are 3 parts that are shaded, that goes in the numerator, and there are 4 parts in total. So therefore, it's written as 2 and 1/4. I hope as we're going through this, you're pausing to try to get the answers on your own before I share it with you. Just in case, we look at one more example, and you can pause to try to get the answer on your own. Here is our last example for mixed numbers. Now, all 4 of these shapes have equal parts. 3 of them are fully shaded, so our whole number in our mixed number will be 3. And the last shape will represent our fraction. Let's count to see how many parts are shaded. 1, 2, 3, 4. Now let's count to see how many parts there are in total, equal parts there are in total. 1, 2, 3, 4, 5, 6, 7. So if these 3 are, we said, are a whole number, and there are 4 shaded parts and 7 parts in total, then our mixed number should be 3 and 4/7. I hope you got that, because now it's going to get a little bit tricky. We're going to move on to improper fractions. But not the reading of them per se. We're going to talk about how to make a mixed number into an improper fraction, or what I like to call how to make a mixed number mad. So in order to make a mixed number mad, we have to follow these steps. First, we want to multiply the whole number times the denominator. Then we want to add the answer to the numerator. And lastly, we're going to put the number over the denominator. So this is how we make a mixed number math, by multiplying, adding, and remembering the denominator. Multiply it, adding, and remembering the denominator. So let's look at an example. 2 and 1/2. So remember, you want to pay attention to the first step, which is multiply the whole number times the denominator. Then we want to look at the second step, which is add the numerator, the answer to the numerator. Now, what did we get when we multiply 2 times 2? Right? We get 4. Now, what do we get when we add 4 to 1? Correct. We get 5. So we take the answer that we got from multiplying and adding, and we put that over the denominator. So our answer should be 5 over 2. So we just made a mixed number math. We multiplied the denominator and the whole number. We added the answer to the numerator, and we put the number over the denominator. So 2 and 1/2 is equal to 5 over 2. We can also see that from our shapes here. So these rectangles are cut into halves, equal parts. So remember, this is fully shaded, this is fully shaded. So that is our 2, our whole number, and then the shaded part is only 1, and then our total of equal parts is 2, so 1 over 2. And another way to look at it is the denominator will be 2 because each part is divided into 2 equal parts. Then you have each two. So denominator 4, 5, 7. Let's look at another example. 2 and 1/4, or 2 and 1/4. Remember, we want to multiply our denominator and our whole number. 2 times 4 gives us 8, correct. Our given denominator, and therefore 2 and 1/4 is equal to 9 over 4. Let's look at our shapes and count the shaded parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 4 equal parts, so 9 over 4. Our last example is 3 and 4/7. So first step, multiply the denominator and our whole number. 3 times 7 is 21. 21 plus 4 is 25. 25, and follow our last step, place it over the given denominator, which is 7. So 3 and 4/7 equals 25. 5/7. And now let's count our shaded parts and our shapes just for a better answer. For checking our answer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Or another way, if you look, there are 3 shapes equally shaded times 7. There are 7 parts in each shape, and then you want to add the remaining of the shaded parts, which is 4, and that gives you 25. Now let's look at improper fractions. We talked about what an improper fraction is at the beginning of this lesson. An improper fraction is a fraction in which the numerator is greater than the denominator. So let's look at a few examples. Here we have 2 of the same shapes with equal parts, all fully shaded. Now, although we just saw the answer right quick, I want you to count the shapes and write your answer. Remember, the numerator is greater than the denominator, and the denominator shows how many equal parts are in each shape. And the numerator shows the number of shaded parts in all of the shapes. So let's look at the answer. The answer is 8/4. So there are 8 shaded parts, and in each shape there are 4 equal parts. So 8 shaded parts goes in the numerator, and 4 shaded parts goes in the 4 equal parts, goes in the denominator. That is what an improper fraction looks like. Let's look at a few more examples before we go on to converting them. Don't forget to pause the video if you need to get the answer before we start talking about it. Let's look at how this can be read as an improper fraction. Five over 3. Let's look at another example. We have 3 of the same shapes divided equally into 5 parts. The number of shaded parts go in our numerator, while the number of equal parts in one shape will go in our denominator. Pause the video here if you want to figure that answer out on your own. Otherwise, let's go. Now we look at our shapes, count them individually. We have 14 shaded parts, and in each shape we have 5 equal parts. So that means our improper fraction will be 14/5. We got our 14 and the equal parts in the shape, in one of the shape, not the number of equal parts, in all of the shape, just one of the shapes. And that answer was 5. So that is how we got our 14 over 5. Now let's look at one more example before we move on. Here we have 4 shapes, all equally divided into parts that are size the same. As I said before, we're going to count the number of shaded pieces that's going to go in numerator, but one of the shapes is going to go in our numerator. Do that together. And all of the equal parts equals to 37. And there are 8 equal parts in each of the individual shapes. So our improper fraction should be 37 over 8. And we're going to talk about how to make an improper fraction a mixed number. Just like how we made a mixed number in add, we had certain steps that we need to follow. The same applies to when we make an improper fraction a mixed number. Let's look at these steps. First is to rewrite as the division equation divide as normal. The second is to write the answer as the whole number. Third, write the remainder over the given denominator. What that means is, when you have a fraction, you want to rewrite the fraction as a division equation, finding out how much of the denominator will go into the numerator. Then, once you find that answer, the whole number, once you find that answer, the number that you, once you find that answer, that is your whole number. You write that and dividing the denominator by the numerator. That's one. How many? Just how many times the denominator goes into the numerator. We're going to do something else with the remainder, remember? So you take the 2 and write it in the whole number spot. Now we're going to play with the remainder. So step 3 says write the remainder over the given denominator. So that's what we're going to do. Take the remainder and write it and put it over the denominator. And that is how we take an improper fraction and make it a mixed number. Let's look at a few more examples. 37 over 8. Remember the steps. The first step is to write it as the division equation. We want to find out how many times 8 can go into 37. I'm going to pause the video to try to do the work on your own. So once we write it as the division equation, we see that 8 goes into 37, 3 times for the remainder of 5. So we take the 3, write it as the whole number, and take our remainder of 5 and put it over our denominator, showing us that 37 over 8 can be converted into 3 and 5 over 8 as our mixed number. I hope you're pausing the video along the way and trying to find the answers on your own. If not, Here's another example. You can pause it now and try to find the answer to this one. 5 over 3. Let's write that as division equation. 3 goes into 5 once, leaving a remainder of 2. We take out 1, divide it in the whole number spot, take out 2 and put it over on denominator, showing us that 5 over 3 can be converted into 1 and 2/3, or 1 and 2 over 3. Now, we looked at proper fractions, we looked at improper fractions, we looked at mixed numbers. We even looked at how to make a proper fraction, an improper fraction, a mixed number, and how to make a mixed number an improper fraction. If for extra practice, you can go back and look at the answers and try to apply the steps that you look back at the answers and try to apply the opposite steps in order to get the opposite result. What I mean by that is how we have this answer here for converting an improper fraction to a mixed number. Apply the rules for making a mixed number an improper fraction and see if you can convert the mixed number back into the improper fraction 5 over 3. I encourage you to try that for all of the examples in order to check the work as well as solidify the steps into your memory. Always, it's a pleasure bringing information to you. For the road, if you want. If not, you can stop the video right here. So let's go through this last one. 14 over 5. We're going to write that as a division equation. See that 5 goes into 14 twice. 5 goes into 14 twice. With the remainder of 4, so we take our 2, put it in the whole number spot, and take our 4, and put it over our denominator, showing us that 14 over 5 can be converted into 2 over 4, which is our mixed number. And that is the end. Thank you for watching, and remember to keep practicing.